Welcome back, everybody. We are going back to and finishing our 7.2 notes on graphing rational functions. So in our last set of notes, we talked about standard form, which is this form right here, the a over x minus h plus k. It already gives us our horizontal and our vertical asymptotes right in the equation as we see it. We also talked about the equation ax plus b over cx plus d and said we can graph that and figure out our horizontal and vertical asymptotes from this equation by doing a little bit of math. So could I change this equation into our standard form equation? And the answer to that is yes, by division. So we're going to go back and review a little bit of our polynomial division. And we have the remainder going in for a up here. The divisor, or the stuff on the outside, is your x minus h. And then the top part, or the dividend, is k. Let's try a couple. I'm going to start with rewriting this as division. So you have 2x plus 1 divided by x minus 3. So x minus 3 goes on the outside, and 2x plus 1 goes on the inside. Remember, we always start with the very first term. So we have 2x divided by x is 2. That 2 multiplies to the x and the 3. So 2 times x is 2x, and 2 times negative 3 is negative 6. This is subtraction. So I'm going to go ahead and change my signs by distributing that negative. 2x minus 2x is 0, and 1 plus 6 is 7. 7 is our remainder. So now, basically, you're going completely backwards, bottom to top, to rewrite it as an equation. So our equation is 7 over x minus 3 plus 2. From here, we know this gives us that our vertical asymptote is at x equals positive 3. And then this plus 2 here says our horizontal asymptote is at y equals 2. Let's try this last one. So we have 3x minus 1 divided by x plus 2. So I'm going to start with the x2 on the outside and 3x minus 1 on the inside. 3x divided by x is 3. We are again distributing the 3, multiplying the 3 to everything on the outside. So 3 times x is 3x, and 3 times 2 is 6. We are subtracting. I'm going to distribute that subtraction there. 3x minus 3x is 0, and negative 1 plus negative 6 is negative 7. We're again going to go from bottom to top when we write our equation. So we have negative 7 over x plus 2 plus 3. And that's a plus 3 because the 3 on the top here is positive. Our equation tells us that our vertical asymptote is at x equals negative 2, and our horizontal asymptote from right here is y is equal to 3. All right, let's graph. So I'm going to start with our division. Yes, we know how to graph this without standard form, but let's turn it into standard form and see what happens. So I have x plus 1 and 3x plus 5. 3x divided by x is 3. 3 times x is 3x. 3 times 1 is 3. We're subtracting, so I'm going to distribute that subtraction. 3x minus 3x is 0, and 5 plus negative 3 is 2. Rewrite it going bottom to top, and our new equation is 2 over x plus 1 plus 3. So our vertical asymptote is at x equals negative 1. Our horizontal asymptote is at y equals 3. My xy table then, remember, is going to be split by that vertical asymptote at negative 1. So I need 3 values less than negative 1 and 3 values more than negative 1. I'm going to stick with boring and predictable here. And so we plug these x values in, and you can either use our new equation, the 2 over x plus 1 plus 3, or you can go back to the original one, but we have to do the math to find the y values. And so I'm going to get 2.33 for negative 4, 2 for negative 3, 1 for negative 2, 0, 5, 1, 4, and 2, 3.67. My graph I'm going to go ahead and put those asymptotes in first. So x is negative 1 is here, and y is 3 right there. Plot my points. Negative 4, 2.33, roughly here. Negative 3, negative 2, and negative 2, 1. First part of my graph. And then 0, 5, 1, 4, and 2, 3.67, which is going to be super close there. And the other part. All right. Please attempt number 2 for the rest of your notes for tomorrow. And we will go over these and do some more practice. Have a great night.